Hello everyone, I am Siddharthan. This is the 10th project video in our machine learning project series, and in this video we are going to build a machine learning system that can predict whether a person has heart disease or not. Okay, so this is the problem statement we have today. So before getting into the hands-on part, I would like to explain you the procedure which we are going to follow for completing this project. Okay, so this is the workflow which we will be following. So it's very similar to the workflows which we have seen before. So the first step is to get the art data. Okay, so this data set contains several health parameters which corresponds to a person's healthiness of the art. Okay, so first we need this art data set. So art disease data set. So once we have this data set, we need to process this data set. Okay, so we cannot feed this raw data into our machine learning algorithm. So we need to process this data set to make it fit and compatible for our machine learning algorithm to learn. Okay, so once we process the data, we need to split our data into training data and testing data. Okay, so this is because we often train our machine learning algorithm with training data, and we will evaluate our model. We will evaluate the performance of our model using the test data. Okay, so this part is called as train test split, where we will split our original data set into training data and test data. Okay, so once we do that, we will feed our training data to our machine learning model. In this case, we are going to use a logistic regression model. Okay, because this particular use case is a binary classification. So we are going to classify whether a person has a diseased heart or not. Okay, so this is a binary classification, either yes or no kind of questions. And in that binary classifications, logistic regression model is very useful. Okay, so it's the best model when it comes to binary classification. Once we train this logistic regression model with our training data, we will do some evaluation on our model to check its performance. So after that, we will get a trained logistic regression model, and to this model, when we feed new data, our model can predict whether that person has heart disease or not. Okay, so this is what we are going to do in our heart disease prediction project. Okay, so I hope you understood the workflow of this project. So now let's get into the hands-on part of this video. Okay, so we will be doing this project in Python, and we will be doing our Python programming in Google Collaboratory. So before getting started with this video, I would like to give you a quick introduction to my YouTube channel. So this is my YouTube channel. So when you go to my channel, so you can see this machine learning course curriculum video. So in this video, I have explained all the modules and the videos which I will be covering in my channel. And in the description of this video, you can download the course curriculum file. So it contains all the video details. Okay, so you can also go to this playlist. So we have already completed about 4 modules in our machine learning course. The first module is on machine learning basics. The second module is on all the Python basics you need to learn about machine learning, and the third is on important Python libraries for machine learning. So in this, I have explained about NumPy, Pandas, Matplotlib, Seaborn, etc. Okay. The fourth module is on data collection and processing. So in this module, I will be explaining you about where to collect data, how to collect data, and what are the various pre-processing text that tasks we need to do in a data set and such kind of things. So we also have machine learning projects. Okay, so we almost have about 9 machine learning projects. So including this, it will be 10 machine learning projects. Okay, so do check out that videos as well. So subscribe and stay tuned for more videos. So you can go to this about section. I have given the link for my hands-on data science course, so you can check that out. I have also given the link for my LinkedIn account and Telegram group and Facebook group. So join in those communities. I will be giving you notifications once I post new videos. Okay, so we will be doing this in Google Collaboratory. So if you are new to this Google Collaboratory, you can check out my module 2 playlist. So here you can see it. So the Python basics for machine learning. So in this playlist, you can see the first video, Google Collaboratory for Python. So in this, I have explained you how you can access Google Collaboratory and what are the various features of Google Collaboratory. Okay. So with that being said, now let's get started with this art disease prediction task. Okay. So first we need to get the data. Okay, so you can search in Google for art disease prediction data set. Okay, so you can see the first site here. So it says art disease UCA Kaggle. So we are going to download the data set from Kaggle. Okay, so this site contains all the information about the data set. Okay, so you can see here, so you can download the data set from here. So this is the download option, and it gives the sample of the data set we have and all the columns of this data set. Okay, so totally we have 14 columns. So I'll just turn this to select all, so it will show the sample for all the columns. Okay, so totally we have 14 columns, and you can see what are these columns are. So we have the age of the person, and the sex, the gender of the person, and the chest pain type. So these are some medical information: the chest pain type, resting blood pressure, cholesterol level, blood sugar level, and those kind of things. So we also have this ST depression and ST segment. So this is based on the ECG curves. Okay, so you can search for this ECG. So you would have seen this in some movies in hospitals. Okay, so where there will be this monitors, and there will be these kind of waves in the monitor. So this represents the functioning of a person's heart. Okay, so this is the wave, how a typical wave looks for a healthy person's heart. Okay, so if there is any change in this wave, that means that person's heart is not performing well. Okay, so it consists of this PQ wave, RST, and RS and T wave. Okay, so and this represents, so we can also have this. So you can see here, so old peak ST depression included by exercise relative to rest. So it represents some abnormalities in this ECG curve. And you can also see this exercise induced angina. So angina means it's pain in the heart which is caused due to low blood in the heart when a person is exercising. Okay, so these are the medical parameters we will be having. And we also have this target column. Okay, so the last column is the target column. Okay, so it contains the value as 1 or 0. Okay, so 0 represents that the person is healthy, and 1 represents that the person has a heart defect. Okay, so we can see it here. Okay, so you can see is here. So the gold field refers to the presence of heart disease in the patient. Okay, so 0 represents no presence, so no heart defect. So other values represent the person has a defected heart. Okay, so this is the data set we have. So you can download the data set from here. So once you download it, so we need to upload it to our Google Collaboratory. Okay, so you can connect your Google Collaboratory environment from here and go to this files options. From there you can upload your data set. Okay, so you can give this upload option, or you can right click here and it will ask you for upload. Okay, so I have already uploaded my data set. So it is named as artdata.csv, so I have renamed it to data.csv. Okay, so this is the data set, so you need to upload it. So once you upload it, we can continue with our work. So the first step is to import the dependencies. Okay, importing the dependencies. Just 1 second. Okay, so dependency is nothing but the libraries and the functions which we need for our machine learning projects. Okay, so here we will import the libraries such as NumPy, Pandas, sklearn, etc. So this is the first step you do in every machine learning project you work on. So first let's import the important or basic libraries. NumPy. So import NumPy as NP, and let's import Pandas as PD. And so I'll also explain you what is meant by these libraries. I'll import sklearn dot model selection. Sorry, so we need to give from sklearn. So from sklearn, so from this sklearn library, I'm importing a specific function, import train test split. Okay, and then so as I've told you earlier, we are going to use a logistic regression model. So let's import the logistic regression model from sklearn dot linear model, import logistic regression. Okay, and finally we need to import the accuracy score from sklearn dot metrics, import accuracy score. Okay, so this NumPy library is used to make some NumPy arrays. Okay, so arrays are like list in Python. Okay, so NumPy arrays and pandas. So pandas is useful for creating data frame. So data frame are nothing but a structured table. So here we have the data in a CSV file. So CSV represents comma separated values, and it is hard. It's kind of hard to analyze the data when it is in a CSV file. So we need to put it in a more structured way, and it is where we use this pandas data frame. Okay, so that's why we are importing pandas library, and we are importing this pandas library in a short form as PD. Okay, so this is the general convention we use. And then we are importing this train test split function. So I have already explained you that we need to split our original data into training and test data, and we are importing this function from this sklearn model selection library. Then we are importing our logistic regression from sklearn.linear model, and finally we are importing this accuracy score. So this accuracy score is used to evaluate our model, to check how well our model is performing. Okay, so we have completed this particular cell. You can press shift plus enter to run this cell and go to the next one. Okay, so this will run this particular cell, and now the next step is data collection and processing. So we have already downloaded the data. So data collection and processing. Okay, so you can, as I've told you, you can go to this files option and upload the data. So once you upload the data, you can go to this options here. So in that you can copy the path of this dataset file. Okay, so I'll copy this path, and now I'm going to load this CSV file to a pandas data frame. Okay, so let's make a comment here, loading the CSV data to a pandas data frame. So pandas data frame are nothing but structured tables. So let's create, or let's declare a variable for this data frame. So let's call this as art data. Okay, so art data is equal to, so we need to use this pandas function. So pd dot read csv. So this read csv function will read a csv file and store it in a pandas data frame. So you need to mention quotes here, and inside the quotes we need to put the path of the dataset file. Okay, so let's run this. So again press shift plus enter. So this has this runs this particular cell. So now we will get a pandas data frame inside this art data. Okay, so now you can see the sample of this data using some functions. So I'll just make a comment here. So now we are going to print first 5 rows of the data set. Okay, so mention the data frame name, which is art dataset, art data dot add. So this add function will print the first 5 rows of the data frame. So you can see the first 5 rows here. So these are the rows which we have discussed, and the last one is the target. So we are going to predict this particular target values. Okay, so either 0 or 1. So this is how you can print the first 5 rows of the data set. So you can also print the last 5 rows of the data set. So let me also show you how to do that. Print last 5 rows of the data set. So again mention the data frame name, which is art data dot tail. Okay, so this add function will print the first 5 rows, whereas this tail function will print the last 5 rows. So you can see the last 5 rows, values in the last 5 rows. And now let's see how many rows and columns are there in this data set. So I'm going to check the number of rows and columns in the data set. So art data dot shape. So let's run this. So totally we have 303 rows and 14 columns. So we have 14 columns and 303 values. That means we have 303 data points, or the data for 303 people, whether these people have either art disease or not. Okay, so it's comparatively it's a very small data set. So a typical machine learning data set may even contain thousands or even lakhs of data, and this is a very small data set, and let's see what we can do with it. So let's get some more information about the dataset. Getting some info about the data. So you can mention the data frame name, our data dot info. So this info will give us some information. So you can see the total number of entries. So there are 303 entries and 14 columns, and we have all the columns here. So there are totally 303 non-null values. So null values means they are missing values. So 303 non-null values means we don't have any missing values. And this D type, so this represents the data type. Okay, so all the data types are 64-bit integer except this old peak column. So it is a floating point. Okay, so there is also another method to check whether this data set contains missing values. So checking for missing values, our data dot is null dot sub. Okay, so let's run this. So it will give us the number of missing values in each column. So as you can see here, we don't have any missing values, so we can use all the 303 values. So in most cases there will be missing values in our data set. So in that cases we can use the methods like imputation. So I have already made a video on handling missing values using imputation, so you can access that video in module 4 playlist in my channel. Okay, so in that I have explained you how you can handle the missing values. So in this data sets, luckily we don't have any missing values, so this is already processed data. Okay, so now the next thing we can do is to analyze the data more. So first let's get some statistical measure of the data. Statistical measures about the data. So our data, so I'm mentioning the data frame name dot describe. So this describe function will give us the statistical measures such as mean, standard deviation, etc. Okay, so you will see the statistical measure for all the columns. So this count represents the number of data points we have in each column, and this mean represents the mean value for all the columns, and standard deviation is, as you know, the standard deviation, and this is the minimum value for each column. And we also have the maximum value for each column, and then we have this percentile values. So these are not percentage, but they are percentile. So percentiles are nothing but, so it says 25 percentile, so it means 25 percentage of the values are less than this 47.5 value in age. Okay, so 50 percentage of the value are less than 55 age. So that is meant by this percentile. Okay, so it helps us to find some insights out of the data. Now let's see how this target value is distributed. So as I have told you earlier, 0 represents that the person does not have any art defect, whereas if the target is 1, that represents the person does have a art disease. Okay, so let's see how many people are there for with art disease, and how many people does not have any art disease in this particular data set. So checking the distribution of target variable. So for this, mention the data frame art data, and in square bracket we need to mention the column name. Okay, so you should mention the column name correctly. So you can see here it all the letters are in small letters, so you need to mention this here in quotes. So art data target dot value counts. So this will tell us how many values are 0 and how many values are 1. Okay, so let's run this. Okay, so series object value count, so it's value counts, so we need to include a yes. Okay, so as you can see here, totally we have, out of the 303 values, 160 people or 160 data points in that value have deceased art or defective art. Okay, whereas 138 people does not have any art disease in this particular data set. So what is the importance of finding this is, we need to have an almost equal number of distribution in the two classes. So here the difference is not very much. So here the distribution is almost even, so there is not any problem with it. If there are about 80 percentage of the values lie in one class and 20 percentage of the value lies in another class, so it is a problem. So in that cases we need to do some processing, but in this case it's not required because the distribution is almost similar. Okay, so I'll just make a text here that 1 represents defective art and 0 represents healthy art. Okay, so we will predict this 0 or 1 by analyzing the other data. Okay, so the next step is splitting the features and target. Splitting the features and target. So here the target is nothing but it's the prediction of whether the person has art disease or not. So it's either 0 or 1. So this particular column is called as target column. The other columns are called as features, because we are going to use all these features to predict this target. Okay, so we will analyze the age, the sex of the person, their blood pressure, and their chest pain, and all the other things. So these columns act as features, and by analyzing these features we are going to predict whether the person has a disease or not. So hence these columns are called as features, and this column is called as target. So as you can see here, this frame, this data frame contains features and the target together, and now we need to remove this target from this data frame and store it separately. Okay, so that's what we are going to do in this splitting the features and target. So I'll create two variables as x and y. So we shall store all the features in the variable x, and let's store the target column in the variable y. So I'll mention the data frame here, art data dot drop. So I'm going to drop the target column. So mention the parameter as columns. So columns is equal to target and axis is equal to 1. So whenever you are dropping a column, you need to mention the axis is equal to 1, and if you are dropping a row from your data frame, you need to mention the axis is equal to 0. Okay, so now we need to store this target column in this y variable. So art data and target. Okay, so let's run this. So this will separate the data into features and targets. So let's print x and y. So now you can see that it does not contain the target column. Okay, so when you print, so you can see here it has 13 columns now. So previously we had totally 14 columns. You can print y now. So this y contains the values of all the target columns. Okay, so it contains 1 and 0. So this is nothing but the target column. Okay, so now we need to feed this x and y to our machine learning algorithm. Okay, so before doing that, as I've told you earlier, now we need to split our data into training data and test data. Okay, so we will split this x into training data, and we will store the corresponding labels or corresponding target for this training data separately and testing data separately. So let me show you how we are going to do that. So splitting the data into training data and test data. Okay, so here, so if you remember, we have imported this train test split function from sklearn.model selection. So I'm going to create four variables here: x train, x test, and y train and y test. Okay, so is equal to train test split, and inside this we need to mention some parameters. Okay, so what I'm doing is I'm splitting this x into x train and x test. Okay, so it means the features are separated as, this x train contains the features of all the training data, and the x test contain the features of all the test data, and y train contains the target of all these features present in this x train, and the y test contain the corresponding target for x test. Okay, so that's why we are doing here. So you need to mention x and y because we are splitting the x and y here, and we need to mention some parameters. So I'll mention this test size is equal to 0.2. Test size, it means like how many how much percentage of the data you want as test data. So 0.2 represents 20% of the data. So generally you can use either 10% of data or 20% of data as your test data. Here I'll mention 20% of data. And stratify, okay, so it's stratify is equal to y. So what this stratify is, so when you mention stratify is equal to y, it will split the data similarly as like this x train and x test contain similar proportion of 1 and 0 as present in the original case. So if you don't mention this stratify is equal to y, there is a possibility that all the values in the x test may contain a 0, or all the values in this x train may contain 1. So such kind of things. Okay, so when you mention stratify is equal to y, these two classes which are either 1 or 0 will be distributed in an even manner throughout your training data and test data as it was present in your original data. And next we need to mention the random state. So random state is equal to, let me put 2. So it is just to split the data in a specific way. And when you are doing this code, if you mention the random state is equal to 2, your data will be splitted in the same way as my data is splitting. Okay, so if you mention 3 or some other numbers, your data will be splitted in a different manner. So this is just to reproduce the code in the same way that I am doing. Okay, so let's put random state is equal to 2. So you can put any number you want. So I'll run this. Okay, so this will split our data into training data and test data. Now let's check the number of training data and test data we have. So I'm going to print the shape of X. So X shape. So X is nothing but our original data set, and X train dot shape and X test dot shape. So X is the original data and X train is the training data and X test is the testing data. So let's run and see how many data points are there in each of these arrays. So as you can see here, the original data set contains 303 values, and our 80% of that data go to this X train, which is 242, and 20% of data, which is 61, goes into the X test. Okay, so we have successfully splitted our data into training data and test data. So now the next step is to train our machine learning model. So I'll make a text here, model training. Okay. So in this case, we are using a logistic regression model because it is very useful for binary classification. Logistic regression model. So, it is named as logistic regression, but it is also used for classification problems as well. So we have imported this logistic regression from sklearn.linear model. So now we are going to use this logistic regression function. Okay. So I'll declare a variable as model, and in this variable, we are going to load our logistic regression model. Logistic regression. Okay, so you need to mention the parenthesis to mention I'm loading one instance of logistic regression model to this model variable. So let's run this. Now we need to train our machine learning model. So we are training the logistic regression model with training data. Okay, so we can use the model.fit function. So this fit function will try to fit X train and X test, sorry, X train and Y train, and this is what a model learning means. So I mentioned X train and Y train. So what happens is it will find the pattern, or it will find the relationship between these features that are present in X train and the corresponding target. Okay, so what happens is it checks this age, sex, and other parameters. Say if there are a particular values, then that person is said to be as a defective art, and if the values are different, then that person is does not have a defective art. And this happens in a more elaborate way when you use this model.fit function. So this machine learning model will try to find the relationship or pattern between the features and the target. So once we train this model, we can use this trained model to predict new values. So that's what is our problem statement is. So let's run this. This will train our machine learning model. So this dataset is a very small dataset. So we add only 300 data points. So hence it trains in a very short period of time. So if you are working on deep learning projects where the data set may be containing 1 lakh of data points or more than that, in such cases the training may take a lot of time. Okay, so this is a small data set, so it doesn't take much time. So this is about training our model.fit. Now we are going to evaluate our model on how well it is performing. So this step is model evaluation, and we are going to use accuracy score as our evaluation metric. Okay, so we have imported this accuracy score from sklearn.metrics library. Okay, so accuracy score is nothing but the model will be asked to predict the target, and this predicted value will be compared with the original target values. Okay, so if the model has predicted about 99 values are correct, let's say we are predicting for 100 values. And for those 100 values, the model has predicted correctly for 95 values. In that case, the accuracy score is 95%. If the model has predicted correctly for 60 values, in that case, the accuracy score is 60%. Okay, so that's what we are going to do. And first, let's find the accuracy on the training data. Accuracy on training data. So I'll create the variable as xtrain prediction, and we are going to we are going to give only the xtrain here. So we have trained our model with xtrain and ytrain. Now I'm going to give this features alone, this xtrain alone, and I'm going to ask the model to predict this target value. Okay, and I'm storing that target value in xtrain prediction, and later I will compare this predicted value with the original values. So mention model. So this is the train logistic regression model. Now model dot predict. So this predict function will help us to predict the target values. So in that, mention xtrain. Okay, so I'm storing this prediction in this xtrain prediction, and I'll create a variable as training data accuracy. Okay, so I'm going to store the accuracy value in this particular variable, and here we are going to use the accuracy score function. So accuracy score, and in that we need to mention xtrain prediction and ytrain. Okay, so let's run this. This will find the accuracy score and store it in training data accuracy. Now let's print it. Print accuracy on training data. Okay, so I'm going to put this training data accuracy here. Okay, so this will print our training data accuracy. So accuracy, more than 75% is somewhat good. And here you can see here we are getting an accuracy score of 85%. So 0.85 means 85%. That means out of 100 predictions, our model can predict correctly for 85 values. Okay, so you can also get more accuracy score. So in this case, we are getting this 85% because the data set we have is very small. So we totally add only 303 values, and in that 303 values, we have used only 242 values for training. So this is actually a good accuracy score, and you can also get more if you use a larger data set. Okay, so that's what you need to note here. So here we have found the accuracy score for training data, but we need to also find the accuracy score of test data. Okay, so I'll just copy this. We just need to change few things here. Now we are going to find the accuracy score on test data. So X test prediction, and here mention X test. So if you remember, we have splitted the data into X train, X test, and Y train and Y test. Now I'm going to find the target for this X test and compare the predicted values with this Y test. So this is the real target values for X test. Okay, so X test. Now this becomes our test data accuracy, and this will be X test prediction and Y test. Okay, so X test prediction model dot predict. Okay, so now let's run this. Let's also print the accuracy score for test data. So accuracy on test data accuracy. So as you can see here the accuracy score is almost 82%, and for training data it is 85%. So there is also another important thing to note here. So the accuracy score on the training data and test data should be almost similar to each other. If there is a wide difference in them, if the accuracy score on training data is way too large and accuracy data score on test data is very small, it means our model is overfitted. Okay, so that we don't want that. So in that case, what happens is our model will overlearn the data in this training data. So we don't want that. We want a generalized learning approach. So this problem is known as overfitting. So in this use case, we don't have overfitted model. So in the future videos, make up what is meant by this overfitting and how you can overcome this overfitting problem. Okay, so in this we don't have any overfitting issue, so we get a good result of about 82%. Okay, so now we are in the last step of our machine learning project. Now we are going to build a predictive system. Building a predictive system. So what happens is, in this system, if you give the values, so all the feature values such as the age of the person, their sex, the chest pain value, and all these features, the model should predict their target. Okay, whether the person has a defective art or not. Okay, so that's what we are going to do in this predictive system. Okay, so the first step is to get the input values. So this input values are nothing but the features. So I'll create a list or tuple as input data. So input data is equal to, so let's fill this input data later. So let's say, for example, I have this data set file here. So I'll open this in a notepad. So let's take some random values. Okay, so you can see here, so the last value is represents the target, and let's take this value. Okay, so I'm going to copy this value, but I won't take this one. So this is the target. So given these values, our model to predict that the target is 1. Okay, so 1 represents the person as a defective one. So let's see whether our model is predicting correctly. So I'll put the value in this input data column, or in this input data array. Now we need to do some processing on this data before we want to make prediction on it. So we need to change the input data to a numpy array. So currently this is in a tuple data type, and we want to convert it to a numpy array because we need to do some processing like reshaping, and it is easy to reshape a numpy array instead of a tuple. So I'll name this as input data as numpy array. Input data as numpy array, np dot as array. So this as array function will convert this data type into a numpy array, and inside this mention input data. Okay, so input data, and the next step is to reshape the array. So the reshaping is to tell our machine learning model that I want to predict the target for only one variable. Otherwise, it thinks that we are checking for 242 values. Okay, so we just need to mention that we need to find the prediction for only one value, and this is the reason for reshaping it. Reshape the numpy array as we are predicting for only one instance. Okay, so it's to tell our machine learning model that I'm just predicting for one feature, or sorry, one data point. So input data reshaped is equal to np, sorry, we can mention this input data. So input data is numpy array dot reshape, and we need to give the shape as 1 comma -1. So this will reshape our array for one instance, and let's create a variable as prediction, and let's store the predicted value of the model in this prediction variable. So as I have told you earlier, we have used this model.predict function to predict the values. So we are going to use the same here. So prediction is equal to model.predict, and I want to predict it for this input data reshaped. Okay, so these are nothing but the feature values that we have copied from our data set. Okay, so input data reshaped. So I'm also going to print the prediction. So this prediction value will either have 0 or 1. So 0 represents that the person does not have any art defect, and 1 represents the person has art defect. Okay, so you can see here we have copied the value for the target one, which means the person has art defect. So let's see whether our model is predicting 1. Okay, so let's run this. So I have asked here to print the prediction as well. So let's run this. So as you can see here, our model predicted 1, so which means it is correct. So it represents that the person has a art defect. Okay, so this is how you can predict for new values by just giving the feature but not telling the target. Okay, so I'll also make a if condition here. So let's make this if statement. If the prediction, So if prediction, so if you can see here, this is printed in a list format. Okay, so we need to mention that if prediction 0 is equal to 0, in that case we need to print the person mm, does not have uh, heart disease. Okay, okay, else, so if the value is 0, sorry, okay, so if the value is 1, so we can mention it in else, print that the person has heart disease. Okay, so what I'm doing is, so this prediction will be given in a list format. So this list contains only one value, right? So that's what I'm mentioning it here. So when you mention a list name, and inside that if you mention 0, it means the first value in that list. Okay, so that's what I'm doing here. So if the prediction value is 0, in that case that person has not, doesn't have any heart disease. So that's what I'm printing. In the other case the value will be 1. In that case I want to print that the person has a heart disease. So now let's run and see this. So it says that the prediction value is 1, and that means the person has a heart disease, right? Now let's also check this for the target 0. So let's get another value. So these are 1. Let's see where the 0 begins. Okay, so here we have a 0, which means that for people who doesn't have any heart disease. I'll just copy another value from here. So let's copy this particular value, and I'm not copying the target, only the features, and I'll paste this here. So now this should give us the prediction value as 0, and that the person does not have heart disease. Okay, so let's try this. So as you can see here, the label here or the target here is 0, which means the person does not have any heart disease. So that's how you can make a predictive system that can predict the target given the features. Okay, so I hope you have understood everything here. So I'll just give you a quick recap of what we have done. So we have, the first step is importing the dependencies. So we have imported some libraries and functions that we need for processing. So we imported NumPy pandas, and we imported this train test split function, logistic regression, and accuracy score from sklearn library, and we have downloaded the dataset from Kaggle, and we have loaded it to from a CSV file to a pandas data frame, and we have seen how to print the first 5 rows and the last 5 rows in a data frame, and we have also checked the number of rows and columns present in the dataset, and we have also seen some information about the data type and whether there are any missing values, and we have also seen how we can check the number of missing values in each column, and we have found some statistical measures of the data set through this describe function. Then we have seen how many values are there for the target 1 and for target 0, and the 1 represents the person with a defective heart and 0 represents a person with a healthy heart. Then we have split the features and target. Here that features are every column except the target, and we have stored all the features in the variable x, and we have stored the target values in the variable y. So we have printed x and y, and then we have split our data set into training data and test data. And then we have loaded our logistic regression model to this model variable. Then we have trained our logistic regression model using the split function. And finally, we have evaluated our model using this accuracy score. And we have seen that we get somewhat good accuracy score here. It's almost 85% on training data and 82% on test data. And finally, the important part is on building a predictive system where when we give a value to this particular input data column, so our model can predict whether the person has heart disease or not. So that's it for this video. I hope you have understood this. So do practice this coach and subscribe and stay tuned for more videos. So I'll be uploading project videos every Friday. So that's it from my side. So thanks for watching.